Now we will be discussing about this parallel lines as well as a transversal, which is of class 9th. Topic is lines and angles. Okay, so now let us see what are these parallel lines. Okay, parallel lines are nothing but if two lines which are lying in the same plane and they do not intersect each other. Okay, first thing is they should be in the same plane and they should not intersect. When they are produced on either side, then such lines are called as parallel lines. Okay, so here L and M are two parallel lines. Okay, if you extend them either side, they will not meet. Okay, and then they will be lying in one plane. Such type of lines are called as parallel lines. Okay, now let us see what is a transversal. So transversal is nothing but a straight line which cuts two or more straight lines, okay, at a distant points is called as transversal. So L is one straight line, M is one straight line. So P is the transversal which is cutting the lines L and M. Okay, this P is a transversal which cutting the straight line at two or more than 2 points is called as a transversal. Now let us see the angles formed when a transversal cuts two lines. Okay, so first let us consider two parallel lines. Okay, this is one parallel line and this is another parallel line. Okay, these two parallel lines are having a transversal. This is a transversal. Let us name this as P. Okay, so this, when this transversal is passing through these parallel lines, it will form certain angles on this. Those are, this is angle 1, this is angle 2, this is angle 3 and angle 4. Similarly here angle 5, angle 6, angle 7 and angle 8. So these are the angles which are formed between these parallel lines. Okay, let us name these parallel lines as L and M. Okay, now we have two types of angles here. Those are exterior angles . Okay, exterior angles are nothing but the angles which are out of this are called as exterior angles. So here 1, 4, 6, 7. Angle 1, angle 4, angle 6 and angle 7 are called as exterior angles. Then we have interior angles. Okay, interior angles. Interior angles are nothing but which are inside the two parallel lines. Okay, this is L, this is M. The angles which are forming in between these two are called as interior angles. So here angle 2, angle 3, angle 5 and angle 8 are called as interior angles. Okay, so this parallel lines and this transversal will make corresponding angles. Okay, so the next one is corresponding angles. Okay, for this corresponding angles, in order to remember this, remember a shape F. Okay, so in the shape F, the angles at this points are called as corresponding angles. If you see here, this is one F, right? So in this 2 and 6 we have, so angle 2 and angle 6 are called as corresponding angles and they are equal. Similarly, you can see one more F here, opposite, right? There we are having angle 3 and angle 7, right? Angle 3 and angle 7. So therefore, those are also called as corresponding angles and they are also equal. Next, if you see here, from this M to this point P, that is also one F, right? It is forming F like this and the angle which we have here is 5 and 1. 5 and angle 1. So therefore 5 and angle 1 are also called as corresponding angles. Similarly, we have one more, that is this one, from this point M to P, 8 and 4. Okay, 8 and 4, angle 8 and angle 4. So these two are also called as corresponding angles. Okay, now let us discuss alternate interior angles. Okay, alternate interior angles. Okay, so what are these alternate interior angles? Okay, the angles which are being formed in the form of Z are called as alternate interior angles. So that means this is a transversal, opposite to this transversal, the angles which are forming are called as alternate interior angles. So if you see here, we are having, this is a Z and we are having angle 3 and angle 5 opposite to each other. Hence, they are called as alternate interior angles and they are equal. Okay, similarly, we have one more Z. If we take like this, opposite, then we are getting it as, okay, here we are having angle 2 and there we are having angle 8. So therefore, these two are also called as alternate interior angles because they are forming in between these two lines. Next, we will discuss alternate exterior angles. Alternate exterior angles. Okay, so what are these alternate exterior angles? Okay, so same here, for the transversal there should be one side one angle, the other side one more angle, then that should be opposite to each other. So here exterior angles are nothing but 1 and 4, 7 and 8. So this is a transversal, the opposite of this we have 4 and 6. So angle 4 is equals to angle 6, as well as this side 1 and 7, angle 1 and 7 are also called as alternate exterior angles. Now let us see what are these co-interior angles. Co-interior angles. So the angles which are formed on the same side of the transversal are called as co-interior angles. So here angle 2 and angle 5 are called as co-interior angles, as well as angle 3 and angle 8 are called as co-interior angles, and the sum of these co-interior angles is 180. Okay, similarly angle 3 plus angle 8 is also equals to 180 degrees. Now let us solve exercise 6.2 problems. Okay, the first one is in the figure, this one, find the values of x and y. Okay, we have to find the values of x and y, and also we have to show that AB is parallel to CD. Okay, so first, in order to find this x and y, what we can do here is, see this is a line and it is forming a linear pair here. Okay, this is forming a linear pair. So let us consider this as P. Okay, so what I can write here is, I have this as PQR, let us take, so PQA, that is, first solution what we can write is angle PQA plus AQR is equals to 180 degrees because they are making linear pair. Okay, so but here PQA angle is 50 degrees plus x is equals to 180 degrees. So from this, x will be equals to 180 degrees minus 50 degrees, that is x is equals to 130 degrees. So we got the value of x, that is 130 degrees. Now here if you see this, these two are intersecting lines, right? PR and CD are intersecting lines. Okay, PR and CD are intersecting lines. So intersecting lines will form intersecting lines. So these are forming vertically opposite angles here, right? This and this are vertically opposite angles. Okay, so therefore by using that y is equals to 130, the reason is vertically opposite angles. Okay, now we got x and y, right? So x is also 130 and y is also 130 degrees. Now if you see carefully, AB and CD in between, these two angles are same, right? What you can see is here angle x is equals to angle y is equals to 130 degrees, as well as angle x is equals to angle y. These are equal because of the reason called alternate interior angles. So if these alternate interior angles are equal, then automatically this is possible only when if these two are lying between the parallels AB and CD. So therefore AB is parallel to CD, because as alternate interior angles are same, this is possible only when they are parallel. So therefore we can prove that AB is parallel to CD. Now exercise 6.2, second problem. Okay, that is in the figure, if AB is parallel to CD and CD is parallel to EF, as well as Y is to Z is 3:7, then we have to find the value of X. Okay, so first let us consider that the given ratio Y is to Z is equals to 3:7. This you can write as Y is equals to 3A and Z is equals to 7A. Okay, next what is given to us is AB is parallel to CD as well as CD is parallel to EF. If AB is parallel to CD, CD is parallel to EF, then automatically AB is also parallel to EF. If AB is parallel to EF, that means this line will become a transversal. If AB is parallel to EF, this is the transversal. So this transversal is forming two angles, that is X and Z. Okay, so what we will write is as AB is parallel to EF and transversal making two angles equal. Two angles, that is angle X is equals to angle Z. They are alternate interior angles. Okay, between these two lines they are formed. This is the first one which I have. Okay, the next we will consider this part now. So X and Y are called as angle X plus angle Y is equals to 180 degrees, because these two are co-interior angles. The sum of the co-interior angles is 180 degrees. But what we have from the first equation, from 1 I can replace the value of X with Z, that is Z plus angle Y is equals to 180 degrees. What do I have? Y 3A and Z 7A. So now let us substitute those values in this, that is 7A plus 3A is equals to 180 degrees. Okay, 7 plus 3 is 10A, which is equals to 180 degrees. From that A is equals to 180 by 10, 0 0 cancel, we are left out with A is equals to 18 degrees. So now we have to find the value of X. X is nothing but Z. So then that Z is given by 7 times of A, which is nothing but 7 times of 18. 7 times of 18, which will give you 126 degrees. Therefore, the value of X is equals to 126 degrees, because angle X and angle Z are equal. Okay, now let us discuss the third problem of this exercise. That is, in the figure, if AB is parallel to CD and EF is perpendicular to CD. Okay, these two are the parallel lines, that is AB is parallel to CD. What is given to us is, in the solution, let us write AB is parallel to CD, and also we have EF is perpendicular to CD, and also we have GED is equals to 126. GED is nothing but this angle, this is nothing but 126 degrees. Okay, so now if you see carefully here, as AB is parallel to CD, as AB is parallel to CD, if you see here, AGE, that is angle AGE is equals to GED, because alternate interior angles. Okay, from that AGE will be equals to 126 degrees. Okay, this is the first one, because GED is given as 126 degrees. So this is the first bit answer. Now second one, we have to find out GEF. Okay, this GEF is nothing but, here it is GEF. If you see carefully, the combination of GEF plus FED, okay, now GEF is equals to, this GEF is nothing but GEF plus FED, which is equals to 126, but this FED is making a 90 degrees. Okay, so we will get GEF plus 90 degrees is equals to 126 degrees. From that, GEF is equals to 126 degrees minus 90 degrees. So therefore, GF is equals to 36 degrees. This is the second bit. Now the third one is FGE. This FGE is nothing but FGE, here the angle. So we have this angle G as 126 degrees. Okay, so now if you see that here it is making a linear pair. Okay, so what we can write is FGE. We are going to find out FGE. So this is by what? AGE plus angle AGE plus FGE. FGE is equals to 180 degrees, because it is a linear pair. Okay, but AGE is having as 126 degrees plus FGE is equals to 180. So FGE is equals to 180 minus 126, which is equals to 54 degrees. So therefore angle FGE is equals to 54 degrees. Let us discuss problem number 4 now. That is, in the figure, if PQ is parallel to, this PQ line is parallel to ST line, and PQR angle is 110 and RST is 130 degrees, then find QRS. Okay, so in order to prove this, let us draw a parallel line which is passing through this R. Let us name this as M and N. Okay, this is the construction. So here it forms angles again. Okay, so now let us write here as PQ is parallel to ST and PQR is equals to 110 and RST is equals to 130 degrees. Okay, this is given to us. Now what we will do is construction. What we have done, construction here is we are drawing MN which is parallel to ST. We are drawing MN which is parallel to ST. If you see this, we are having PQ is parallel to ST and MN is also parallel to ST. So from this what you can write, then automatically PQ also will become parallel to PQ is parallel to MN. Okay, so by using this, now here if you see, angle PQR plus MRQ are co-interior angles, right? That is, angle PQR plus MRQ. MRQ is equals to 180 degrees because co-interior angles. Okay, in that I have the Q value as 110 degrees plus MRQ is equals to 180 degrees. From that I will be getting MRQ as 180 minus 110 degrees, which is equals to 70 degrees. So I got MRQ angle as 70 degrees. Now similarly, if these two are parallel, if MN is parallel to ST, then here also we are having angle TSR plus NRS. NRS is equals to 180. Same reason, co-interior angles. That is, angle at the point S is 130 plus NRS is equals to 180. So from that, NRS is equals to 180 minus 130. So NRS is equals to 50 degrees. Okay, so now we got this as 50 degrees and this as 110 degrees. Now we have to find out QRS. This is nothing but this angle. Okay, in order to find out that, now on this MN, this is making a linear pair. Okay, on MN it is making a linear pair. So it will become what now? MRQ, angle MRQ plus QRS plus NRS. NRS is equals to 180 degrees. Angle at the point R is 110 and we have to find out this QRS plus NRS is 50. So this will become 180. So from this, QRS will be 180 minus, if I add these two, I will be having 110 plus 50 will become 160. If I shift it that side, it will become 180 minus 160. So it will become 20 degrees. So therefore, the angle QRS is 20 degrees. If AB is parallel to CD and APQ is given as 50 degrees and PRD is given as 127 degrees, we have to find the values of X and Y. Okay, this is X and this is Y. Now we have given AB is parallel to CD. Okay, in that case, if you see APQ, that is angle APQ is equals to, what we can write is RQP, which is equals to 50 degrees because alternate interior angles. So now this is, if we consider this as a transversal, okay, these two are the alternate interior angles. So therefore we got the angle of X as 50 degrees. Okay, now let us see this side. That is, we have to find the Y. Now again, if we consider AB and is parallel to CD, now APR, that is angle APR is equals to DRP, which is equals to 127 degrees. Okay, so now this complete angle will become 127 degrees because this is an alternate interior angle for this. What is the reason here? Alternate interior angles. Okay, but now if you see this, that is angle APR. Angle APR is a combination of APQ plus we have QPR. Okay, so that is APR is nothing but complete angle, which is 127 degrees, is equals to AP angle is 50 plus P angle is Y. So from that, 127 degrees minus 50 degrees is equals to Y. From that, Y is equals to 77 degrees. Okay, this is how we found X and Y values in this. Now the last problem of this exercise, that is, in the figure PQ and RS are two mirrors. Now these two are mirrors, PQ and RS, which are placed parallel to each other. These two are the mirrors which are parallel to each other. So now we are considering an incident ray. This is AB is an incident ray, okay, which strikes the mirror at the point PQ at the point B, and then the reflected ray will be moving in the straight path at the point BC, and it will be intersecting the mirror at the point RS at C. Again it will reflect back to the point CD. So prove that AB is parallel to CD. So here AB is the incident ray, so this is the reflected ray. Again this is the incident ray for this ray, and this will be the reflected ray. Okay, so here what we are doing is, given that PQ is parallel to RS, these two are parallel is given to us, AB, BC, CD are rays. Okay, so now what we have to prove? AB is parallel to CD. So in order to prove this, I am drawing a perpendicular line BM perpendicular to PQ, CN perpendicular to RS. Okay, so now let us see the proof of this. Here PQ is parallel to RS. This is PQ, which is parallel to RS, as well as we are drawing two perpendiculars, that is BM is perpendicular to CN, right? If these two perpendiculars are also will be parallel, that is BM is parallel to CN. Now here angle 1 will be equals to angle 2, similarly angle 3 will be equals to angle 4, because they are incident angles and the reflected angles. So here angle I is equals to angle R, that is angle 1 is the incident ray and angle R is the reflected, that is angle 2 is the reflected ray. Okay, similarly angle 3 and angle 4 also same. We are writing this as equation number 1. Now let us consider the angle 2 is equals to angle 3, because BM is parallel to CN. BM is parallel to CN, and this is the transversal, and the angle 2 and angle 3 are making alternate interior angles. Okay, so that's why angle 2 will be equals to angle 3. Let us name this as equation number 2. From this 1 and 2, if we equate, we are getting it from 1 will be equals to 2, 2 will be equals to 3, and 3 will be equals to 4. Just by equating first and second equations, we got all the 4 angles are equal. So now I am adding angle 1 plus angle 2 and angle 3 plus angle 4. If I add angle 1 plus angle 2, I will be getting ABC. Similarly, if I add 3 plus 4, I will be getting it as BCD. Okay, these two are nothing but the alternate interior angles of these two lines, that is PQ and these are the two interior angles of AB as well as CD. That is, therefore these two lines, if they are parallel, then only they will become alternate interior angles will be same. Okay, hence the lines AB will be parallel to CD.